parametric equations. So we've got our two equations, x equals and y equals, both in terms of t, and we're asked to find the exact value of dy by dx. So what we need to remember before we start this, so for this one, dy by dx is equal to dy by dt divided by dx by dt. So that's the key thing to remember here. And if you wanted to have a look at that, that's because when you divide by two fractions, you would flip the second one and make it multiply, in which case the dt's would cancel, leaving you with dy by dx. But obviously that's just your theory there. So what we need to do in order to solve this problem is to work out what those two things are. So we want to find dx by dt. So that's differentiating the first equation with respect to t, and we want to find dy by dt, so differentiating the second equation. So if we start off with this first one then, okay, so we need to just think about what x is actually doing here, and I'm going to, it's two terms with a common denominator, so it's 4 over 4 minus a quarter of e to the 2 minus 6t. Okay, so that's the same as writing it as 1 minus a quarter e to the 2 minus 6t. So we know that when we differentiate 1, that just goes to nothing. So that's going to go. So we're just now really looking at what happens here. So what I'm going to show you is how you do this with the chain rule. So if you need to use the chain rule, that's absolutely fine. So it's minus a quarter e to the u. That's effectively what your x is equal to. And u is equal to something ill with t. So it's minus 2 minus 6t. So dx by du, differentiate this, so e to the u will just stay as e to the u, so it's still minus a quarter e to the u. And du by dt, okay, that's going to give me minus 6. Okay, so then multiplying these things together, I get dx by dt is equal to minus, two minuses, the minus from there and the minus from there, 6 over 4 e to the u, which is 2 minus 6t. So for me, coming up here, going to put our dx by dt in, we get 6 over 4 or 3 over 2, which is now positive because the two minuses have cancelled, e to the 2 minus 6t. Okay, so I'm just now going to just leave this up for a second, just in case you're copying that down, and then I'm going to remove it so we've got space to find dy by dt. Okay, so dy by dt then, y is equal to e to the 3t over 3t. Now, what we need in this case is we need to identify that we've got a fraction, i.e. we've got a quotient. As if by magic, the quotient rule appears. So the first function, the top function, f of x, is going to equal e to the 3t. And our second function, the bottom function, g of x, is going to equal 3t. So f dashed of x, so if I'm differentiating this, and if you want to, you could use chain rule, but the standard result is 3e to the 3t. Differentiate that. We are differentiating with respect to t, not with respect to x. And then g dashed, so they're not really functions of x, are they? They're functions of t. It doesn't make any difference whatsoever for this question, but let's just make sure that the notation sort of makes perfect sense. So that's 3. And now we're going to use the rule we've got here and put everything in. So that's going to give us dy by dt. Okay, so we've got f dashed of x, which is 3e to the 3t, times by g of x, which is 3t, minus f of x times g dashed of x, so times by 3, and all of that is divided by g of x squared, so 3t squared. So tidying this up, I'll put it over here now, dy by dt is going to be 9t e to the 3t minus 3e to the 3t, all divided by 9t squared. Now that's the order in which you write each of these terms is not overly important. you've just got to make sure that you get something like that. So that's giving us our dy by dt. And once again, I'm just going to remove some of this workings to give us a bit more space. Okay, so we've got dx by dt, we've got dy by dt. So now we're just going to put this all together. So dy by dt, which is the top thing here. So I've got 9t e to the 3t minus this one, all divided by 9t squared. That's on the top of my fraction, and on the bottom of my fraction is 3 over 2 e to the 2 6 minus t. So that's what dy by dx is equal to. And we're asked to find the exact value when t is equal to 2/3. So we're now going to substitute t equals 2/3 into this here. Now, there is other simplification you can do with your fraction rules and things, but actually this should work out without too many problems and will give us our marks as we need it. So I'm going to take my time with this when I'm substituting in. So it's 9 lots of 2/3 e to the 3 lots of 2/3. And so if you can do this in one step, then that's absolutely fine. But for the purposes of this video, I'm just going to take my time and show you the full working. So that's all going to be divided by 9 lots of 2/3 squared, and that's divided by 3 over 2 times by e to the 2 minus 6 lots of 2/3. So hopefully you'll notice that everything that we've got here does come to reasonably nice numbers. 3 times 2/3, for example, is 6 over 3, which is 2. So let's just give ourselves a bit more room. So I've got 9 times 2 over 3, so 18 over 3, which is 6 e to the 2 minus 3 e to the 2. And that numerator is being divided by 9 times by 4/9. Okay, so 4/9 is what happens when we square 2 over 3, times that by 9. Obviously the 2 9s cancel, leaving me with 4 over there. So that's my numerator, and all of that is being divided by 3 over 2 e to the, and if we have a look at what's going on here, I've got 2 minus 12 over 3, which is 4. Okay, so my next stage is to write this. The top here, 6e squared minus 3e squared, leaves me 3e squared over 4. And that is being divided by 3 over 2 e to the minus 2, 2 minus 4. Now, if we just write this slightly differently, the 3e squared over 4, that's the same as saying 3/4, or if you like to try and make this make perfect sense for you, 0.75 e squared. That's being divided by 3 over 2, which is 1.5 e to the minus 2. So we're doing 0.75 divided by 1.5. And I'm just going to prove this using the calculator here. 0.75 divided by 1.5 is a half. So what we've actually got here is an equivalent fraction to a half. And then I've got e squared over e to the minus 2. Now this e to the minus 2 here is the same as writing e squared up on the top there. So it's not e squared over e squared, it's actually e squared times another e squared, because 1 over e to the minus 2 is the same as e squared. So I'm using that to bring myself down here, which then gives me the final solution of a half e to the 4, which is the solution in the mark scheme and what we're looking for. So the fractional bit here, I appreciate, is kind of not quite as standard as we're expecting. We might want to do something quite using sort of bringing different fractions up and things, but this is certainly the easiest and fastest way to get ourselves down to the answer for this one. Once again, I'm going to remove our workings for here, and then we'll have a look at the next part of this question. So part B then is looking to show a rearrangement. Now, the important thing with this part, so I'm just grabbing the pen, the important thing with this part of the question is that there's a very key step that the mark scheme wants you to get to in order to get the first mark. So if you got yours marked and it didn't have any marks, but you've got somewhere, have a look against the mark scheme to really see what it was that you had to do next. So let's just start off with what we've got. We've got x is equal to 4 minus e 2 minus 6t all over 4. So what we're trying to get to is something where we've got e to the 3t is equal to. So first step, as always, really when you've got a fraction, is just to try and get rid of that fraction. So we'll do that, and we'll get the e term on its own. So I've got 4x minus 4 equals minus e 2 minus 6t. Okay, now at this point I'm going to get rid of that minus on this side in front of the t, in front of the e term, because again I'm thinking, where am I going? It doesn't have a minus in front of it. So if I divide or multiply through by minus 1, I'm going to get 4 minus 4x, which is equal to e 2 minus 6t. Okay, at this point you've got to remember your Indices Law that says that if you've got an index minus another index, that's the same as saying equals e squared divided by e to the 6t. So that's what it means when you've got an indice divided by another indice. We can write that as a single index with a negative between them. So what we're then doing is we want to get something in the form where e's on the top of a fraction and we've got something on the bottom. So I'm going to multiply both sides by 6e to the t to give me e to the 6t, don't know where I got that from. 4 minus 4x is equal to e squared, and then divide by the 4 minus 4x. So I get I get e to the 6t equals e squared over 4 minus 4x. So the mark scheme wanted you to get to something like this before it gave you the first mark. And then it's just noticing that we can effectively square root both sides. Now to square root, I'm actually going to show you it's putting to the power of a half. Okay, that's the same thing as square rooting. So what you'll see is going to happen here is these two indices, 6t and the half, are going to multiply. So we get e to the 3t, which is what we wanted. And then everything in here is getting square rooted. So I'm going to square root e squared. And I'm going to square root this. But before I do that square root, I'm going to factorise it. So I'm going to write it 4 1 minus x all square rooted. And the reason I'm doing that is because I know where I'm trying to get to. And I've just cut that off the top here, so it's just difficult to spot. But let's just scroll up for a second. This is where I'm trying to get to. So I want a 2 out the front and then a square root of 1 minus x, which I'm very, very close to getting to now. So coming back down to where we're at, the top of this, the numerator, e squared square rooted, is going to leave me with e. And the bottom here is going to give me root 4 times by root 1 minus x. And then we know that root 4 is 2, so then we've actually shown, as we've been asked to do, e over 2 root 1 minus x there. Okay, and that's worth 2 marks for us. So once again, I'm just going to delete this workings and then we'll have a look at the final part of this question. Okay, so part C then, and again, this is 2 marks. This is a tough 2 marker, okay? I think this is one of those situations where really it's only 2 marks, so it's, if you're not quite with it and you don't see how this is working, then don't worry too much. We've been asked to show that the first one rearranges into this. So what this is telling me is that this is going to be useful for this x term, because what we're going to try and do is obviously eliminate the t part of these 2 equations. So if we take this one, e 3t equals e over 2 root 1 minus x. Okay, now I'm going to try and get this in terms of t, or in fact in terms of 3t, because what I want to do is I want to sub it in to y. I want to use it for the y term, because if I know what I know what e to the 3t is, I just want to know what 3t is. So if I take logs of both sides, So log of e to the 3t equals log of e over 2 root 1 minus x. These two are going to cancel, leaving me what 3t is, and I get this logarithm. And remember, this can be written similarly to what we've done already as the two things taken away from each other. So I've got ln e minus ln 2 root 1 minus x. So actually I can write 3t as 1 ln e minus ln 2 root 1 minus x. Okay, and what you may have already noticed is, oh, that's that bit there, 1 minus a logarithm of a function of x. So then what we've got is y is equal to e3 to the, e to the 3t over 3t. Now I'm going to rewrite this slightly differently. I'm going to rewrite this as e3t over 1 times by 1 over 3t there. Okay, so what I'm doing here is I'm just showing you that when we're doing this, when we substitute in, how this is all going to work. Okay, so this should make sense that that's the same as y. So now let's put in what we know. We know e to the 3t. That is e over 1 minus root 1 minus 2 root 1 minus x. And we're going to multiply that by 1 over what 3t is, which is 1 minus ln 2 root 1 minus x. And using this notation instead of the division, and the problem with the division is that we get a bit confused with what's being divided by what. But in this notation, it's then really easy to see that we've got e on the top here, and we've got these two things are being multiplied together. So this function of x is going to be 2 root 1 minus x, because we're doing that one multiplied by 1 minus ln 2 1 minus x. So it's one of those situations where it is difficult to spot, and I said at the beginning that it's 2 marks because effectively it's really difficult. But if you spot this, it's then really simple. If you try and substitute them into here and here, you've just got to really have your head switched on to how we're going to go about sorting out that division. But if we expand the division, I think it's really easy to see what's going on.